Hello, awesome Algebra 1 students, and welcome back. In this video, we're going to be solving systems of equations using the substitution method. The substitution method only works when you have an isolated variable or it's simple to isolate a variable. So the step one is to substitute the value of the isolated variable into the other equation and solve for that variable. So that could be solving for x or solving for y. Step two, take that value of x or y, substitute it back into the original equation to find its matching value. So if you were given a value of x, plug it in to find y, and if you're given a value of y, plug it in to find x. And then as always, check your solution in both equations. So in this video, we're going to be looking at some examples from a worksheet and some examples from IXL. Okay, let's go ahead and start it off with some examples from this worksheet. So solving each system by substitution, again, what you need every single time is an isolated variable or a variable by itself. So in this case, we're starting with a pretty simple example. We know that y equals 2. So this equation is giving us that value of y. So in our final answer, which again, remember your final answer is going to contain an x value and a y value, we already know that the value of y is 2. So we already know that. We can use that information. So how do you find x if you know the value of y is 2? Well, you're going to go to the second equation and you're going to plug into for y. So in other words, if I write out the second equation, 7x minus 8, I'm taking out y and I'm replacing it with what I know it equals. It equals 2. And then I'm finishing off the rest of the equation. Now I'm just solving for x. So 8 times 2 is 16. So I have 7x minus 16 equals negative 9. To solve for x, I'm going to add 16 to both sides because that creates a 0 term. That leaves me with 7x equals negative 9 plus 16 is 7. And then I'm going to divide both sides by 7 because that creates a big 1 factor. And that gets me with x equals 1. So I know my solution, or I think my solution is 1, 2. But again, remember, it's always a good idea to check. So in the first equation, there's really nothing to check because I already know y is 2, so check. But in the second equation, I'm going to go ahead and plug in 1 for x and 2 for y. And that gives me 7 minus 16 equals negative 9. And 7 minus 16 is negative 9. So I know that my solution is also correct in my second equation, and I feel confident that I got that one correct. Now, in the second example here, this one's a little bit tougher because we do have an equation with an isolated variable, but not like the first one. This isn't giving me what x equals. It's telling me x is equivalent to 3y minus 7, but I can't exactly plug that into I can't exactly plug that into a solution. I can't, for my final answer, which is going to be a value of x and a value of y, I'm not going to put 3y minus 7 here. That would just be silly. But the rest of it kind of matches what we did in the first one. We know that x is equivalent to 3y minus 7. So what we can do is we can substitute that for x in the first equation. So what does that look like? Well, if we start to write the first equation, we start with negative 3, but I'm taking out x and I'm replacing it with 3y minus 7 because that's the expression that x is equivalent to. And then I finish writing off the equation, minus 3y equals negative 3. Now, this is the same idea as over here in the first one. Here I was solving for a value of x. Here I'm going to solve for a value of y. So to do that, I first have to distribute. So negative 3 times 3y is negative 9y. And negative 3 times negative 7 becomes positive 21. Bring down the rest of the equation. Then I can either subtract the 21 or combine like terms. I'm going to go ahead and get that 21 out of there. It's bugging me. I want to get it out of there. So I subtract the 21 because that creates a 0 term. And that leaves me with negative 9y minus 3y equals negative 24. Combine like terms, negative 9y minus 3y is negative 12y. And divide both sides by negative 12. And I get, because that's a big 1 factor, and I get y equals 2. So now I have found that y equals 2 here. I wasn't given that information. I had to use what I was given, the fact that I knew x was equivalent to this expression, to find that y equals 2. Now, I'm only aware of half of the solution at this point. So I need to go find the other half, meaning just like this one, I now know that y equals 2. So what can I do with that information? Well, I can plug it into either equation to find the value of x. It doesn't really matter which equation you use. If I plugged it in here, that would require some solving and some negatives with x. So maybe I don't necessarily want to do that. It looks to me like it would be easier to plug in y equals 2 in that second equation. So that's what I'm going to go ahead and do down here. I'm going to take that equation. I now know that y is 2, so I'm going to plug that in. That gives me x is 6 minus 7, and 6 minus 7 is negative 1. So it appears my solution here is negative 1, 2. Now, I do want to check, because it is always good to check, and I'm kind of out of room here, but I'll do the best that I can. I'm going to go ahead and do a mental check. So negative 3 times negative 1 is 3. 3 times 2 is 6. Does 3 minus 6 equal negative 3? Yes, it does. So it works in the first equation. And then I already kind of know that it works in the second equation because I did that math, right? Like I used this equation to find the solution. So if I were to do a quick mental check, does negative 1 equal 6 minus 7? Yes, it does. So I know it checks out in the second equation, and I know that this must be the solution to the system. So again, you always look for an isolated variable, and whatever that isolated variable is equal to or equivalent to, you substitute that in and solve. Okay, so now we're going to look at some examples using IXL. This is IXL Code 8P9. So again, the beginning examples are going to be a little bit simpler, and then they'll get a little bit more complex. So in this one, we're given, just like in our first example, we already know what y is. So in our final answer, remember, the first number is x and the second number is y. So what I know I can do here is I can go ahead and put negative 1 for y in my final answer, because I already know that y is negative 1. Now I don't know what x is, so that part I'm going to have to figure out. So basically I'm taking negative 1 and I'm going to substitute that for y. So that means I have 4x plus 9, take out y, replace it with negative 1, because that's what I know it equals, and it's going to help me find the rest of my solution. That would be 4x minus 9, because a positive times a negative is a negative. Add 9 to both sides, because that creates a 0 term. 4x equals 19 plus 9 is 28. Divide by 4, because that creates a big 1. And we get x equals 7. So in this case, because I knew y is negative 1, I used that to plug it in. I got x was equal to 7. Let's go ahead and see if that's right. And it is. Second equation, very similar to our first one. This time we're given what x is. So if I know that x is negative 9, I'm going to go ahead and put that into my solution, negative 9. And why did I put it as the first number this time? Because again, remember, solutions are ordered pairs. The first number is x, the second number is y. So now I know that x is negative 9. I'm going to plug that into the first equation for x. So that's 4 times negative 9 minus 4y equals negative 12. So negative 36 minus 4y equals negative 12. Add 36 to both sides, because that creates a 0 term. We have negative 4y equals 24. Divide both sides by negative 4. Whoop, that creates a big 1 factor, and y is negative 6. So over here, I know that my answer is negative 6, or at least I think so. We'll see. And I hit submit, and woohoo, awesome. All right, I'm going to jump a level here to get to something a little bit more challenging. Okay, so this is a very interesting example. You'll notice here that both of these equations are solved for y. Y is isolated in both. This just means that because both of these are equivalent to y, think of it as I'm either taking this expression in the first equation and substituting it into the second one, or I'm taking this expression in the second equation and substituting it into the first one. Now here's the thing, because they both equal y, they're both going to equal each other one way or another. Either I'm taking negative 4x plus 6 and substituting it for y here, or negative 3x plus 4 and substituting it for y here. Either way, you end up with negative 3x plus 4 equaling negative 4x plus 6. because they're both equivalent to y. So now we have an equation with variables on both sides, which means I'd like to put my line in so I don't mess up and separate them. And then I have options. I can create, I can add 3x to both sides, subtract 4, add 4x to both sides, or subtract 6. I don't like to deal with negative coefficients, meaning I don't want to add 3x to both sides because that would make a negative 1x here, and I don't like that. So I'm going to add 4x to both sides. You can totally do it the other way, but this way I don't have to deal with negatives. It makes a 0 term, and I'm left with 1x plus 4 equals 6. Notice how I put my equal sign on the line. Now I can subtract 4 from both sides, and 1x is the same thing as just x. So I end up with x equals 2. Again, didn't have to do it that way, but that's how I chose to solve it because it has the least amount of steps. Now that I know that x is 2, I need to go find y. Pick either equation, it doesn't matter. Let's say I wanted to use the first one. I'm going to plug in x is 2 into that first one. So y equals negative 3, replace x with 2 plus 4. So y is negative 6 plus 4, and negative 6 plus 4 is negative 2. So I believe the answer here is 2, negative 2. Now, just for the sake of argument, let's go ahead and look at what would have happened if I plugged in x into the second equation instead. Let's see, y equals negative 4 times 2 plus 6. Y equals negative 8 plus 6. And guess what? You still get y equals negative 2. So it doesn't matter which equation you use as long as you're doing your math correctly. Let's hit submit here and see what happens. Looks like we were correct. Whew, thank goodness. So it's another one where you would plug them both in for y. Let's go ahead and do one last one. This is a tougher example, so we'll end with this one. In this one, you'll notice that we don't have a variable by itself, and you have to have an isolated variable in order to do substitution. So if I'm looking at both of these equations and I'm like, okay, I need to isolate a variable, which one is as close as possible to being isolated? You're going to look for a variable that doesn't have a coefficient. What stands out to me is that y is kind of standing on its own here. All I would have to do is get rid of this 3x. That means I don't have to do any type of division. I just need to get rid of the 3x, and boom, I will have an isolated variable. So if I'm going to solve for y here, that just means get rid of that 3x, subtract it from both sides. That creates a 0 term, and you have y equals 14 minus 3x. Now I have an isolated variable, which means now I can substitute this expression for y in the other equation. Let's go ahead and do that. So here we go. In this equation, now we have 4x minus 2. Take away the y and replace it with 14 minus 3x equals 12. Okay, for here, we need to do some distributive property, but be careful here when you're distributing. Keep in mind that that's a negative 2 that you're distributing. That's where the most common errors are made. So we have 4x minus 2 times 14 is 28. And then negative 2 times negative 3x makes this a positive 6x equals 12. I like to get rid of those 28s in the middle or whatever terms in the middle before I combine like terms. So I make that a 0. And I'm left with 4x plus 6x equals 30, and 10 is 40. 4x and 6x is 10x. Divide both sides by 10. I'm totally running out of room here. That's a big 1. And we get x equals 4. See, that wasn't so bad. 4. Now, here's the thing. If you're going to plug in to another equation, I always say plug into an original equation. So I may have done this math wrong, so I wouldn't want to take 4 and plug it in here unless I was 100% certain that I did that right. So to be sure that you did your work right, I always suggest plugging that 4 into one of these two equations, okay? One of the originals. So it looks like, again, the math would be easier if I do it in the top equation. So let's go ahead and plug in 4 for x in the top equation. It doesn't matter. You can do either one. I'm just predicting which one will give me a little bit of an easier time. Subtract 12 from both sides, and we get y equals 2. See, that wasn't so bad. Okay, over here, y equals 2. Let me get all these drawings out of the way, and there you go. Okay, that concludes this video. Again, remember, for substitution, you must have an isolated variable. If you do, go ahead and substitute into an equation, solve for a variable, substitute again, solve for the variable, and then always check if you can. Have fun solving with substitution, and I'll see you next time.